Welcome to the Explainer. Today we're going to demystify something that really feels like everyday magic. You type a question, you hit enter, and boom, in a blink of an eye, you get answers from the entire digital universe. So how is that even possible?
Well, to really get it, you first have to appreciate the scale of the problem. The amount of information out there is just staggering. And it's not just big, it's growing exponentially. It's like a digital Big Bang that just never, ever stops.
Right, so searching this absolutely colossal universe in milliseconds seems completely impossible. But the solution isn't some kind of magic trick. It's actually a really elegant system, and it's built entirely on the power of teamwork.
Let's put it this way. Imagine a single, super-fast librarian. They're trying to read, index, and shelve every new book that arrives, every single second, while also running around finding answers from millions of people at the same time. No matter how fast they are, they'd be completely overwhelmed, right? Well, a single computer faces that exact same problem.
So, instead of trying to build one ridiculously fast librarian, you do something much smarter. You hire an army of them. And that is the absolute core principle of distributed computing. You take an enormous problem, you smash it into thousands of tiny little pieces, and you have thousands of processors tackle them all at once.
Okay, but just having a giant team isn't enough. You could have total chaos. This is where the real genius of search comes in. You need a brilliant strategy to divide up the work so the whole operation runs like a well-oiled machine. In the world of computer science, this strategy is called data partitioning. It's all about how you slice and dice that infinite library, that index of the entire internet, and assign sections to your team of digital librarians. And it turns out there are two main ways you can do this.
So, you've got a fundamental choice. The first strategy is called document partitioning. You can think of this as slicing the library horizontally. So each of your digital librarians is responsible for a specific set of websites. Maybe you get all the sites that start with A through F. The other one gets G through L, and so on. The second way is term partitioning, which is a vertical slice. This is totally different. Here, each processor becomes an expert on certain words. It handles any query that contains those terms, no matter where they show up online.
And this is where the crucial trade-off happens. Document partitioning is way simpler to build, but your librarians might waste a ton of time searching whole aisles that have nothing to do with your query. Now, term partitioning is more efficient. You go straight to the expert librarian, which is great. The catch? It's way more complex to manage, and if a topic is super popular, that one expert librarian can get totally swamped, creating a massive bottleneck. That's why a search engine might use the simpler document approach for a general web search, but the specialized term approach for something like an image search, where the keywords are more defined.
Now, you can't have a massive team with a complex strategy like this without a leader. It would be pure chaos. In a search system, this master coordinator has a name. It's called the broker.
You can think of the broker as the ultimate project manager. It takes your search query, instantly breaks it down, and sends the little tasks out to all the right processors. And then, as all those partial results come flooding back in, the broker gathers them, combines them, and ranks everything to give you that single, clean list of answers you see on your screen.
So what's the broker's number one headache? It's making sure no single processor, no one librarian, is doing all the work, while the others are just, sitting around. This is a classic, super important computer science problem called load balancing.
And this picture shows the goal perfectly. On the left, in a well-designed system, the workload is beautifully balanced. Every single processor is pulling its weight. But on the right, you see an unbalanced system where some processors are totally overworked and others are basically idle. This is the kind of thing that can happen in those more complex setups. So achieving that perfect balance you see on the left, that is the secret to getting that millisecond speed.
So everything we've talked about so far, the partitioning, the brokers, the load balancing, that's how one massive search system works. But to conquer the entire internet, you have to scale this model up to a truly global level.
This slide really shows that evolution perfectly. We started with a parallel system. That's our one giant library with many librarians inside. Then things grew into a distributed system. So now imagine you have branches of that same library in different cities all over the world, all connected and coordinated. And finally, we have the federated system. This is like different, completely independent library companies, each with their own rules, all agreeing to cooperate and share information. And modern search, it's a massive, incredibly complex hybrid of all three of these.
So the next time you type something into that search bar, just remember this invisible dance that's happening. You're not just asking one computer a question, you're activating a global team of millions of digital librarians, all working in perfect harmony just for you. But here's the thing, this is not a solved problem. As our digital universe keeps expanding at this crazy pace, the challenge to organize it all and search it effectively is only going to get harder. The real question is, what comes next? What's the strategy that comes after partitioning and brokers? That's a challenge that's going to define the entire future of how we access knowledge itself.